Hey guys, welcome back. In the last video, we discussed differential equations and how to integrate them. We started by separating variables, and then we solved for a constant c, and then we rewrote the expression or the equation in terms of y. So now we're going to do growth and decay problems. So let me begin by first integrating y prime here equal to 2x over y, the differential equation. So as I showed you in yesterday's video, what we're going to do is we're going to first rewrite y prime to be dy dx equals 2x over y. Then I'm going to cross multiply because I need to separate the variables. So the y has to go here, the dx has to go next to the 2x. Okay, so we have this expression. You must write this down on your paper to show the AP reader what you're doing. You cannot just jump from here to here, okay? So you got to separate the variables first. So now we're going to integrate the variables, okay? So with respect to y, the integral of y is y squared over 2. With respect to x, the integral of 2x is x squared over 2, and the 2's will cancel out, and then you have a plus c. So in this video, I'm not going to plug in for a c or find the initial condition. We're basically done solving for this or integrating it. In many applications, the rate of change of a variable y is proportional to the value of y. If y is a function of time t, the proportion can be written as follows. So what I have here is the highlighted portion, and I'm going to try to just rewrite word for word in terms of an equation. So y is the same exact thing. So the rate of change of the variable y. The rate of change of the variable y is dy dt. The word is means equal, proportional to the value of y. Proportional to the value of y means k times y. So if you go and do what we just did to integrate this so we can write the y as a function of time t, what I'm going to do is k is a constant. I'm going to leave it here. Y is a variable. I'm going to put dt here and then divide by y. Now I'm only going to do this once, and then you guys can sort of skip this, this step over here. So I put the k dt because k is a constant. Always leave your constants next to the dt or the dx. And then I'm going to integrate. The integral of this, 1 over y is natural log of y, and the integral of k with respect to t is kt plus c. Now, since I don't have any initial condition, I'm just going to raise the other side to e kt plus c. Now, in yesterday's video, I showed you something very special. I said, right, you can separate the exponents, because if the bases are the same, you can add the exponents, so you can go backwards. E to the c is just a constant, so we're actually going to rewrite it like this. In some books, or some mathematicians, they want to call this C1, this C1, this C2. It doesn't matter. It's just a constant. So you can just rewrite it just like this without any notations. So this is the formula for growth and decay, okay? So let's try one of the problems. The rate of change of, not that kind of y. Okay, I was speaking into the iPad. The rate of change of y is proportional to y. So you're going to have to extract at least 2 pieces of data. So here it says when t equals 0, y equals 2. Then they said when t equals 2, y equals 4. What is the value of y when t equals, I should have not done it that way, but when t equals 3, what's the value of y? Because it says the rate of change of y is proportional to y, you want to start with this. Okay? Now, what I always think about is solving for Calvin Klein, CK. So what we're going to do is you're going to use the initial condition. You have to remind yourself of a few things. Anything to the 0 power is 1. So let's put the 2 in here. C, e to the k times 0. K times 0 is 0. E to the 0 is 1. Therefore, you solve for C. Go back and substitute here. 2e to the kt. You must write your function in terms of y and t only. So we got to solve now for k. So that's when I use my second condition. So what I'm going to do here is I'm going to put 4 equals 2e to the 2t. You divide by 2, okay? And now, in order to get rid of an e, because the e is holding an exponent, what you're going to do is you're going to take the natural log on both sides. Natural log touches e, brings down the exponent without the e. You divide by 2. Never in your entire life allow that 2 to go into 2 to make it a natural log of 1. That would be incorrect. You would have to actually use your calculator to do natural log of 2, get that answer, and then take half of it. Okay, so your final answer is going to be approximately, I'm using a calculator, 0.3466. That's for, you guys should have stopped me. This is a K. My apologies. You're plugging in to solve for K, so you plugged in for T. Okay, so 0.3466. So now you solved for C, now you solved for K. You basically can write y as a function of time t. So it's going to be y equal to 2e to the 0.3466 t. Now that you have the function, you can pretty much solve for anything. So you can just plug the 3 in here, exponent first, e to the power times 2. For anybody who's trying it, your answer should be 5.657. Okay? So let's try another problem, but we're going to use an application. So basically for this, you have to solve for C, then you have to solve for K, and then you can solve for whatever you want. Okay. So here it says, suppose an experimental population of fruit flies increase according to the law of exponential growth. So once again, we will use the y equals CE to the KT. There were 100 flies after the second day. Okay. There were 300 flies after the fourth day. Okay. How many flies were in the original population? Okay. So we're going to see what we can solve for. So this is going to be a little bit tricky. So I'm going to start with using my first condition that I have. Y equals, t equals 2, y equals 100. So I'm going to go 100 equals C e to the kt. So that's 2k. Can't do anything here. There's too many variables. Okay, there's no any, in this problem, it was k to the 0. So we were able to get rid of, here we have nothing. So now we're going to use the second one. 300 equals CE to the 4k. Great. So now what I can do is you can pause the video and try to figure it out by yourself, but some people will divide straight through. Some people will solve for C and plug in. Either way works. So what I'm going to do is I'm going to actually write the larger number on top, and then I'm going to actually divide it. Divide both sides. 300 over 100 is 3. C over C cancels each other out, right? So this cancels out with this. When the bases are the same, you subtract exponents. So 4k minus 2k is 2k. You're going to take the natural log of 3, natural log of e. Natural log of 3 is equal to 2k. So the natural log of 3 divided by 2 is equal to k. Once you guys are done with that, you can plug it into either equation. I'll plug it into the easier one. And so what I'm going to do here is 100 equals CE to the 2 ln of 3 divided by 2. The two 2's cancel each other out. So now you're left with 100 equals CE e to the natural log of 3. So you just use your calculator. You're going to go 100 divided by the natural log of, this is so simple. I don't know why I'm doing that. E to the natural log of 3, guys, is just 3. E touches ln, it just leaves you with what's inside the ln. So there is 33.33 flies in the beginning. Why? Because anytime you're looking at exponential growth, and you've probably seen this in chemistry or physics, this right here is always your initial or your original population or your initial. So since you solved for C, there's going to be 33.33 flies originally. Okay, or since you can't have 33.33, it's 33. So that's how you do that. Remind yourself that the natural log and E, when they touch each other, they just disappear. Okay, I have 2 more examples, but I have them already laid out for you just to give you another idea. If you feel like that's enough, that's great. If you feel like you got the hang of it, if not, just watch the last 2 problems. 4 months after he stops advertising, a manufacturing company notices that his sales have dropped from $100,000 or 100,000 units, that's your initial, to 80,000 units. Remember, they said 4 months later. It says if the sale follows an exponential pattern of decline, what will they be after another 2 months? So you can't use the number 2. You got to say, what is it when t equals 6? So once again, I'm going to do y equals ce to the kt. I'm going to use my initial. This is great. And basically, if you want to skip this step, anytime you guys have t equal to 0, you can skip this step because this part will be 1. Because isn't it true that e to the 0 power is 1? So if you substitute t to be 0, it'll be 1. So you're left with 100,000. Then you use the second. You put 80,000 equals 100,000 e to the k times 4. So this should be here 4, okay? Then you are going to take the natural log on both sides. Natural log touches e, you're left with 4k, and then you divide. You solve for k, you get negative 0.0558. So as a function, your answer here would be, I think I wrote on the next page, so let me just see. Yes, as a function of time t, we have 100,000 e to the negative 0.558 t. So when t equals 6, 2 months later, you get this. So all you have to do is solve for c and then k, okay? One more. Newton's law of cooling states that the rate of change of the temperature of an object is proportional to the difference between the object's temperature and the temperature of the surrounding medium. So, if an object in a room whose temperature is kept at a constant 60, so the room is 60 degrees. So we're going to take y minus 60. If the object, should not say cools, but should say cools from 100 degrees to 90 degrees in 10 minutes. So originally, it might be like hot chocolate. You get 100 degrees in the beginning. 10 minutes later, it gives you 90 degrees. How much longer would it take for his temperature to decrease to 80 degrees? So how many more minutes do we need? So now we're going to give you 80, and t is how much? So I give you this formula, okay? You wouldn't have to remember it or anything. So y prime is dy dt. You have to separate the variables, bring y minus 60 here. You're going to integrate. Remember, it's y to the first, so it's a natural log of y minus 60. The integral of k with respect to t is kt plus c. I'm going to have to use this initial condition 0, 100. So when you put 100 for y, you get the natural log of 40. When you put t to be 0, you get 0. You're left with c. So therefore, c is equal to the natural log of 40. Now we have to use the second condition to find k. So we're done with this. We found natural log of 40. So that's your c. So I went back to my equation and I plugged in for c. You should never solve until you solve for c. So now I'm going to plug in 90 degrees 10 minutes later. So I get natural log of 30. I'm going to subtract natural log of 40 on the other side, and then I'm going to divide by 10. You have to use your calculator. Please do not assume this is 30 minus 40 or any of that. So you have to use natural log of 30, enter, minus natural log of 40, enter, divided by 10, enter. You get your k to be this. So now I'm going to put my k back into, remember step 3 from yesterday's video, and I'm going to raise this power to the e. And then I'm going to be left with y minus 60. Pause the video if it's going too fast. E to this plus this, remember you can separate this. So e to the natural log of 40 is just 40. That goes in the front, and then this is left here. Add 60 to the other side. You now have your function. Now that you have your function, all you have to do is plug in 80, solve for t, and you guys should get 24.09. So I hope that was helpful. Just to recap really quickly, all you need is basically 2 points. Solve for one, solve for the other, and the rest is just basic math. Okay, have a great